Okay, and now it seems like we're finished, but I think that this can be a very good opportunity to start learning how to program with data tree structures inside of a C# component. So what we're going to do is to define our output lines in the form of a Grasshopper data tree. But I'm going to do a spoiler right now, because in fact when Grasshopper refers to a data tree structure, so the elements that belong to that tree, they do not make reference to the whole tree, but just to the last generation of that tree. So that's what we're going to do. We're going to define our small branches here in the way of a data tree structure. Okay, and now in order to assign an element to a tree, what we need to do is to define the path in which we are going to assign it. So for that, let's define a new parameter for our grow branches function, which will be the path in which we are going to add these new branches. So as we said, what we are going to add into the tree, it's just the last branches of our tree, but we have to keep track of the tree growth in order to define our paths properly. So for that, these are my first path. So for the first additional branch, we are going to add a new path with the value of 0, and for the second additional branch, we're going to add a new branch, a new element to this path with the value of 1. And of course, we have to add these new path parameters or path variables in the function that we are calling. Okay, that's right. And of course, when we are calling this function inside of the run script subroutine, what we are going to do is to start with a Grasshopper path as well. In this case, let's define the path 0 to start growing our path and eventually assigning these branches into our tree. Okay, and finally, so let's say that our recursion function gets eventually to these branches here. So that will happen when the length is smaller than 1 and we are not growing additional branches. So in this case, let's add an else condition here, or consequence, better said. And if that happens, if we are on the last branch of our tree, what we are going to do is first to remove the last element of our tree, because we don't need that anymore. We are not going to grow new branches. And then we are going to add that particular branch into our tree that we already defined as a global variable here. Okay, everything looks nice. So now the only thing that we need to do is to add that tree into an output parameter of our Grasshopper component that I haven't defined yet. So I'm going to get an error as soon as I close this component. But here is where we will output this tree structure. And of course, this is the error because we haven't defined this parameter yet. Let's define it and reset it. And now we have another error. I'm sorry, because we already defined a variable with this name. Let's take a look into it. Yes, so we have to use, of course, path 2 here and path 2 for the other new branch. Okay, let's try it again. And everything looks nice. And instead of growing our tree, I'm more interested now into the tree structure that we are getting here. So as we can see, our tree structure is made up of just the last branch of our tree. And if we take a closer look into it, we can see the tree structure here perfectly. So our first branch, we can take a look into this path to understand better how this was created. So the first branch starts with the path number 0. This is the tree trunk, and then takes 0 again, and then 0 again, and then 0 again, and then finally we have our 2 branches here. if are two elements, sorry, it can be confusing because this is an actual tree. So then if we move on to the next element, it would be, instead of using the path number 0 here, it would be the path 1 at the end of our path structure. So this is basically how trees work. And in this case, let's take a look into the last branch finally. So in this case, it starts with the element 0 here, and then it uses 1, 1, and 1 once more time. And finally, we have our two elements here inside of our tree. So this is how tree structures work actually. And the most important thing is to understand which kind of meaning, so which meaning do these paths have, and also that a tree structure doesn't mean that we are using the whole tree, but just the last generation of branches, let's say.